Sounds like we are live. Live. Which one is? This should be on. I think we are live. Yeah. Hi everyone. Hello. Hello everyone. I'm gonna try and monitor the comments. I'm gonna try and see them today, so I'll try and make sure I can see the comments as much as possible. Well, yesterday we worked on a binary counter. And it was really nice because we ended up learning a bunch of Verilog testing or simulating issues that we kind of went through. And I still haven't found out why it couldn't simulate the way we wanted it to, but we worked on a binary counter. Now, the one thing that I wanted to realize from yesterday is we got introduced to a register. And a register sort of introduces us to the concept of state in Regi transfer level, RTL or hardware definition languages, because wires, you can make a bus with a wire, like you can make a 4-lane, 8-lane, 32-bit lane with a wire, but they can't really hold state, you see? And then registers can hold state, and until you assign them again, you don't really have to change them. But then this sort of brings us into like some weird territory where we have to kind of contend with how things go fast. How do we make things go fast? And previously I've written a little CPU over here. I've written a little CPU over here, tiny CPU. Where's the tiny CPU? I've built a tiny RISC CPU previously, and it's sort of slow. Hey Nathan, how are you? Yeah, actually Nathan was around when we were doing this CPU. The thing about this CPU is that whenever we're doing something, we have to sort of go, whenever we get an instruction, we have to go and do the actual instruction at the point. So we have to like interpret the whole instruction, realize what is going to be done, and then once we realize what the instruction is going to be, then we actually go, we have to fetch the instruction. So we have to go read the instruction from we usually have like an instruction register or something, or actually from ROM. We have to read the instruction from ROM, and then we have to load it up, and then we have to understand it, and then we have to go a further step and do some execution on that instruction, which is like a lot of work. And this basically brings us to this concept of clock-driven work, which is actually something we did yesterday when we worked on our. I'm gonna be jumping around concepts today before I do this. When we worked on our binary counter, when we were looking at it, it was clocked. So every time the clock rose, we did something. So this sort of starts to show that there's this opportunity to optimize, the opportunity to build things better, to make them faster. And almost by mistake, we walk into a really, one of the, I just want to reply. We walk into a really advanced concept or rather to me, I think it's quite advanced, which is sort of like pipelining. And pipelining is sort of like this in pipelining in computing, instruction pipelining. So let's keep it at this. It will get to a point where it's both, but this is sort of the beginnings of introducing parallelism. This is sort of where we start doing two things at once. So in computer engineering, instruction pipelining is a technique for implementing instruction level parallelism within a single processor. Pipelining attempts to keep every part of the processor busy with some instruction by dividing incoming instructions into a series of steps, known as the eponymous pipeline. I actually don't know the meaning of that word, eponymous. Does anyone know the meaning of the word eponymous? What does eponymous mean? Just give me a moment, guys. and I'm back. I had to send a message. So what is the meaning of eponymous? Of relating to or constructing an eponym. Whoa. Named after something else or deriving from an existing name or word. So the eponymous pipeline. Okay, cool. So instruction pipelining is named after the thing that is called a pipeline. And basically, I think it's already explained it in a certain way here, which is pipelining attempts to keep every part of the processor busy with some instruction by dividing incoming instructions into a series of sequential steps. And these sequential steps are things like fetch, decode, execute, fetch, decode, execute, fetch, decode, execute, or fetch, decode, store, execute, and on whatever on this arm. But we're not going to jump straight into that. I think the first part we want to do is we want to start realizing how this thing is achieved. And one easy way is reading this document, which is Micropipelines by Evan E. Sutherland, who is an American computer science person. It's linked in week 3 of hands-on FPGA advanced reading, asynchronous design using micropipelines. So asynchronous design. It's sort of like this is again we're really introducing the concept of being parallelized. We're doing things not on just one clock, but on multiple levels. So what I wanted to introduce here is I wanted to introduce a system here that has, say, 3 registers, and in these 3 registers, what I wanted to introduce is sort of like something called a two-phase bundle convention, where we have a sender and we have a receiver, and both of them kind of share data between each other. And then by them sharing data between each other, what we can start to do is we can start using both ends of the clock. When the clock, so currently our RTL binary counter always uses the positive edge, and even in our test cases, we always use the the one that was there before this. We would use a positive edge, we would use the rising edge, or we would use the falling edge. It doesn't matter, but the thing I'm trying to expose here is that we would use one of the edges of the clock. And what we want to introduce is a concept where the thing that we're trying to understand is a concept where we are basically arrested to transitions and transition signaling. And I'm going to zoom in here so that people can see, but this is a paper that's online, and let me remove that so you can see that. Yeah, so you can see the link if you want. So let's read this and then we'll see. And I'm going to read this part. This is the part I'm reading. So I just realized I can zoom like that. Okay, cool. So in transition signaling, either rising or falling edge has the same meaning as illustrated in figure 2. Either kind of transition is called an event, as indicated in the figure and suggested by its name. Transition signaling avoids distinguishing between the 2 types of transitions. Even though they might look quite different, in effect, all responses to transition signals are edge triggered and are triggered on both the rising and falling edges. So, and I might be mistaken. So I might be a fool and I might be looking at this wrong. This leads to many other concepts that we have observed. A few weeks ago we looked at MIPI, and MIPI introduced us to something called DDR. And DDR is double data rate. Double data rate. This is a hugely common thing today. Is if you have DDR RAM in your computer, this is what happens. And then double data rate describes a computer bus that transfers data on both the rising and the falling edges of the clock signal. Hence it doubles the memory bandwidth by transferring twice per clock cycle. So you can see here. So these are the kinds of things that once you start understanding them, they start introducing this sudden jump or this sudden boost in speed. And before you can read this paper, and I would encourage you to read this paper because we're going to spend maybe another few days on this and try and end up in building some sort of pipeline, or at the very least understand pipelines at a very intuitive level. So that way we can get to a point where we are just implementing them. Uh, and we are even getting to a point, I'd like us to get to a point where we're going into the ARM code, or we're going into the RISC-V code. There's this VexRISC CPU, RISC CPU. You know, just like we do with just like we do with just like we do with how do I say it? Just like we do with Zephyr. What we want to do is get to a point where we can read other people's code. Okay, and once we can read other people's code and we can understand what other people's code is doing, you move way faster. I'm trying to see if they actually push their generated RTL. I'm trying to see if the RTL is actually pushed up. I don't see it. But what we want to get to a point is where we can look at some existing CPU, some existing, let's see, open RTL RISC-V CPU. Hey Nathan, did you ever buy an FPGA? So we want to get to some place where we can come into some CPU like this, and we can open it up and we can start looking at how it's, this is probably the system very low one, the RTL one. This is the internal and external and whatever of those. So we want to get into some place like this, be able to open a module and start to understand where's the pipeline, what is it doing, where is it going, why is it going there, why is it not coming from this way? Because at that point we're at a point where we can look at code that exists and start to actually catch up, start to stand on the shoulders of giants, rather than having to reinvent everything from the basics or from the beginning. So that's kind of what we want to build into. And even though we've written our own CPU, it would be good to understand how other CPUs work. That way it'd be quite simple for us to, start implementing. So in today's kind of little example, what I want to do is use this guide. I see Nathan. Use this schematic over here as an example, and find a way of implementing this schematic in RTL. That way we can build this sort of double data rate transfer thing going on. Because once we can build these things, and then you can start augmenting them, start modifying them, start kind of like just adjusting them as you go, they become really, really easy. And whenever you have like this solid ground you can go back to and you can relate to things from that solid ground, it becomes really easy to start understanding other things. Hence also why we're using a paper from 1989, by the way. This is nothing new. This is actually, in this case, older than me. Sorry about that. Well, I don't know why I'm apologizing for being sick. My wife wouldn't like it. But so let's fire up our let's try and see, what happens. What happens? Can we actually achieve this? And if we achieve this, what happens? Can we do it? Can we make it so that it works on one clock, on two clocks, or can we even just make this kind of transfer of data achievable and write a test bench for it so that we can observe it actually working and then see from there? So let's go do that. If anyone has any questions, right now is a really good time because I'm setting up. If anyone has any questions, that's right now is a really good time. Documents and yep, dear RTL micropipelines pipelines dot start. Can we set things? I don't even need to set things. Micropipelines. CD RTL micropipelines. Oh yes, it's in the it's on the repo. It's in the description of. So Nathan is asking, can I share the link for the 8-week FPGA thing? Yes, it's on the thing. It's on the description of this video. At least you'll get a link to the one, and then you can go back and get to the own thing. But it should be on the repo. I haven't put it on the repo yet, but it's on the link to this video. So check the link for this video. Let me see. Let me see. Is it on the link? It should be on the link to this video, and you should be. I mean, is it not? It's not. Thank you, Nathan. So this is the thing that we're following. Thank you, Nathan. Hands-on FPGA course. Okay, cool. I saved it. I put it on the link to the video, so you should be able to see it now, Nathan. Thank you for letting me know. Okay, cool. But it's basically hands-on FPGA by Tiny Vision, and amazingly enough, Nathan, by the way, amazingly enough, this course was taught to Kenyans in, I think, 3 or 4 years ago. This whole thing is prepared for Kenyans. I didn't know it. I only found out about it this year when I joined the company. But this whole course was prepared by Professor Venkat for Kenyans, and he taught it over an 8-week period, I think during COVID, to Kenyans. I missed everything, and I'm having to read it by myself, so it's a bit sad for me. But yeah, let's go set up this project anyways. So up here, create. Up here, Control R. Up here, create. Arduino mode 3. Yeah, that's fine. Let's set it up as a, and then nvim, and then we do that. And then the thing I want to do, the first thing I want to do is actually let's make a .getignore. Why can I not type? And then in here we want to ignore the build folder, and then we can also just make readme md, and we can say I hash micropipelines. Project that follows this white paper and other bits of information. Okay, so let's get this white paper in from this lesson. That way when people find these things, they can, let's just make it easier. Let's make the world a better place than we found it, okay? Okay, cool. So that gives us some documentation, and that gives us everything. So now actually let's go make a main.v. And as always, my editor is going to be a little silly. So first of all, this is default net type none. You should always start your Verilog with this module main, and then we don't think our module is gonna take anything, and then end module. And then that's that, and then I'm gonna do this, and then so that when I come back in, something like this, so that when I come back in, I get syntax highlighting. That's just pardon me for that. Okay, cool. So what is it that we want to do now? What is it that we want to do? We want to implement such a relationship of data, and if we want to describe this, shall I read this to describe this? If a sender and a receiver use if a sender and a receiver communicate using transition signaling, it feels so bad to lecture based on someone else's lecture. I feel like I'm stealing. This is life. If a sender and a receiver communicate using transition signaling, there will be two control wires and many data wires between them, as illustrated in figure 3. And the data wires carry conventional high or low states to convey true or false Boolean data. The sender places a data value on the data wires and then produces an event on its control wire called a request to indicate that a valid data are available. And in some cycles, the request event will be a rising transition, and in some it will be a falling transition. We make no distinction between them, and the receiver accepts the data and then produces an event on its control wire called acknowledge to indicate that the data have been accepted. The three events, data change, request event, acknowledge event, always follow in a cyclic order, as illustrated in figure 4. Successive cycles may take different amount of times, as suggested by the difference in length of the cycles in the figure. Sometimes other than request and acknowledge are used for the two control wires. You may wish to compare this to the non-overlapping clock of figure 5. So I'm not gonna lie, I don't want to make it too complicated. I could read this. I enjoy reading stuff like this. I enjoy explaining stuff like this. I enjoy learning stuff like this. But I don't want to make it too boring. So let's write some code and see what happens. And I think the first thing I want to do like reg. Okay, so let's do a couple of signals. Let's do a couple of signals. So there is reg. Is it supposed to store? Yeah, it is supposed to store. The default value of a register is 1 bit. So reg receiver, reg rx equals 0, and then reg tx equals 0. Okay. So let's just leave it at that. Let's say this. Very default Verilog register size. I think it should be 1. Register data type. Variables Verilog. There, yeah, there you go. You see that? Reg enable. But the point I wanted to make here is the default Whoa. Default. Yeah, default size. The default size is 1 bit, basically. So if we say this, we get 1 bit, and it is it's that. Okay, cool. And then let's go down and then go look reg data box, and then we want to do we actually want to declare size. Let's make it a 4-bit 30, and then let's actually say this is for base 0, isn't it? Yeah. And then let's say reg actually we can actually go for b1. Yeah. And then let's make another one, reg 30. I don't want to use wires yet because there's something I cannot think, and sometimes it's not that I don't know what to do, it's just that I don't know how to think in hardware yet. Because we can use wires, and then we can't connect one end of the wires to the receiver and one end of the wires to the transceiver. To the transmitter, not to the transceiver. To the transmitter, But then how do I scope what data it is? I haven't learned how to own wires yet. Let's say this. Our Xbox, and then we're gonna say that this is supposed to be tabbed actually, by the way. In order to write proper Verilog, this is supposed to be tabbed. Well, what? No. Yeah. Yes, so these are supposed to be tabbed as well. Yeah, so that it looks proper. And that. Yeah, and then this equals to four bits of 0. And then let's do another edge here, and then we can go 3 0, and then we can say tx box tab is equals 4b0. So I don't know how to own wires yet. I probably knew. I probably know, but I'm just like over complicating it in my head. So I don't know how to own wires yet, and because of that, we're gonna use 3 registers. We're gonna be copying between 3 registers. So we want to do an always at let's think about this. So always at pos edge or neg edge transmitter. Let's start with the transmit one. Well, which is we want to send data. So we want to send data, but we want to do something, and then well, it will be done at the second transition. So always at pos edge or neg edge pos edge or neg Verilog quick reference. Let's get the quick reference. Control F, or I want a space before. Space before. I'll zoom in the moment I get what I'm looking for. Yeah, there's an or. Control plus. Yeah, there's an or. There is an or keyword, but I want to look at registers and nets. This is kind of what I want to do, but I won't look at them right now. It's fine. Let's just look at the pipelines that we wanna. Is there a neg edge? You see, there's a pos edge over here. Let's look at edge. Okay, let's look at edge. Yeah, there is a neg edge. Okay, neg edge. At pos edge clock or neg edge. How do I use both edges? How do I use both edges? How do I use both edges? Please show me how do I use both edges. So there's an and. Yeah, always at pos edge that. So how do I use both edges? Pos edge or neg edge. No one's showing it. At pose edge that. No, I want to use both edges. Yeah, something like that. Because I want to use the transition. At pose edge. Yeah. At clock or pose edge. Neg edge reset. So they want me to do, is it? So pose edge. Yeah, there. Pose edge clock or neg edge clock. Okay, cool. So I need to say pose edge RX, no TX, or neg edge TX. So yes. So when I'm sending, this means this is the receiver action. Do you see what's happening here? So this is going to be the receiver action. The receiver, looking at this schematic. Look, we have a transmitter, we have a sender and a receiver, and the sender does the request and the receiver does the acknowledge. So whenever the receiver gets this, the receiver does something. They copy the data. This, you see this this dotted line, receiver's action. See here. So this is the receiver. Whenever the receiver does this, it's the receiver that reacts. I mean, the receiver is the one that reacts to the TX, and the transmitter is the one that reacts to the acknowledge. So let's actually do that, and then begin end. Yeah, and then what I want to do here is the receiver is the one that's doing what is the receiver fills RX box with data box. So RX box is somewhere data box. Is this kind of what we want to do? This is kind of sort of what we did yesterday in our RTL binary, isn't it? I just want to get really comfortable with this. Yeah, so that's fine. So we set it to that, and then always, and then what does this do? Always, and then what happens here? And then what happens here? Then once we've done it, once the receiver has done it, this should be blocking. Once this should be blocking, because we should not, yeah. This should be blocking. I think we can do an assign here. Appear lint. Am I allowed to do that? Unexpected always. Why is it always unexpected? Why is it always unexpected? What did we wrong? What did we missed some syntax somewhere? Module main, default net type, all of those. Yeah, here. Perfect. It lints. It's good. So this is the receiver action. The receiver copies that, and then once the receiver copies this, it goes like assign. It flips the RX. It flips RX goes not RX. Yeah, so receiver flips it, and then here, and then always You don't want to do anything. Nathan is asking, what do you want to do differently on the rising edge versus the falling edge? Look here, Nathan. Look here, Nathan. Transition signaling. In transition signaling, any transition, either rising or falling, has the same meaning as illustrated in the figure. So basically, they're the same thing. We're basically, if right now we're just using a little, we're toggling bits. But imagine if we had 100 megahertz clock. If we had 100 megahertz clock and we were using transition based stuff, we would be able to do 200 megahertz rate of data. So you don't want to do anything differently. You just want to use every transition as an opportunity to do work. Basically, that's what I'm saying. So always at pause edge. I know. So this is amazing. So we don't even have to ping pong data. We can just do it. I see. At pause edge. So we don't even need data box. We don't even need data box. We just need our X box. Our X box, TX box. So let's do TX box. Yeah. This is actually becoming wires by itself, because we could actually then if some sort of thing was sampling here, then we would let's pause edge RX or neg edge TX begin, and then in here what we want to do is, do we want to asynchronously do it or do we want to do it synchronously? I think I want to hold the clock until I'm done. So I'm gonna go like assign TX box is equals TX box plus 4B1 plus 1B1. This is actually nice because then we can see the data bubbling through. And now it's not a, previously when I was writing this in the beginning, I was seeing it as like a ping pong thing, and now I realize I can just manipulate the data in the sender so that it's just new data every time, and we can see something going on. And then I would go assign, and then this is blocking as well, assign TX equals not TX, and then I would end, and then this is the thing, and then this is the thing, and then so and in beginning I would trigger. This is how I would trigger the thing. I would go, this is how I would trigger it. Can I go TX? Yeah, TX is equals not TX. This is a procedural assignment, I think, something like that. Let's link. Can we link this? What happens here? So unexpected that, expecting a this. Expecting it that. Why is that not expected? Can I do an assign? So the next, it's just an assign here. Initial begin. So what do I want to do? How do I want to do it here? How do I trigger this thing? How do I trigger this thing so that when it starts, I want to flip it? Have we done this before? Have we done this sort of setting up before? How do we trigger it? We do set it here, we do set it here, we do set it here. But I want to do, I don't want to do an always. I want to do like a one time. A one-time one. I think this is in Verilog assignments. let's go back to here, let's go back one, let's go back to here, and let's look at week 2, and then let's look at this father reading zip CPU, and I think we want to look at some sort of assignment here. There's something here that's going to give us an assignment. Circular logic, something like that. So I want to do some sort of like assign here. You see that? It does do an assign w internal dot. So do I want to like remove I think tx. So this is that. Yeah, sure. So I could do that, and then just before the thing starts, I could go like assign. What is it? It's not. Yeah, it's an equal. So assign equals tx. Assign tx equals not tx. How do I do this? What is the construct I'm missing here to do this? No, I'm missing some construct that sets it up. I'm missing some construct. I'm missing some construct. I am missing some construct. There's something I've forgotten how to do. No, this is fine. This is fine. I need to do like an always. No, I don't want to do an always. I want to do a one-time setting. I basically want to do a one-time setting. I want some sort of input from outside the module to trigger it. Yeah. Look at this. This is what we need. This is what we need. So we need to go like input start. This is really, but this now becomes a main module, and we don't want to do an input on our main module because then we would have to use a pin for it. So this becomes pipeline, and then I go here and I make a main.v, and pipeline main.v. Yeah. Okay. So let's go in here and we can remove everything in here. We can just remove that, and we can remove that. And what we want to do is this, for this to be named main. Okay, that's fine. And then I want to go here, and then I'll go v d. And here I want to put this so that it's valid, and I want to go into pipeline.v, and I want to start, and then I want to go here and upon starting, always at pause at this one, and this is just at pause edge, so this is just a pause edge of at pause edge start. So it's clear that pipelines live inside things. They're quite deep because you want something. This should have been quite obvious to see, but pipelines need something to start them. So tx equals not tx. That's it. And let's see what happens there. Input start. Yeah, this does not need to be. There's no need for this here. So that should be good. That should be good. So what did we just do here? So whenever the actually we can do a begin here. Right? Let's do a begin here because they're both 0. Let's even set that tab 0, and then let's actually set this as 4b0, 4b1. We can just trigger it and we can leave it alone. This is actually better because we get more varieties of Verilog that we've written. So look at it this way. We need something to start our pipeline, and then once our pipeline is started, eventually we will need some sort of thing to stop it. And yeah, but don't worry about it. Don't worry about the stopping. So we can just bubble through for a few, and then we'll see what happens. And we can always do. And it's finish. Verilog finish. Is this synthesizable? No, so it's not. So finish is not. How about stop? This is okay. So stop. You will probably need to. We can't use some Verilog magic code to actually do it. So okay. So let's go write a very simple observer. Let's go write a very simple observer thing to see that actually this works. Because if we go up your build, this looks like it builds okay. Okay, yeah, so we need to make a PCF file. PCU. Let's go, it's just a main.pcf. There's nothing to be put in there. There's nothing, we don't have to do anything in there. Token assign. This is something we've done somewhere wrong. Where is it? In what? Main.v. Is there an assign in here? Let's look at the pipeline. Up linked. Build. Pipeline V number 16. So there's something up. That's. Can I go begin? And why is number 16 unexpected? Why does it? Am I doing this wrong? Can I just do it like that? I don't know why that would be. Yeah, something is wrong. I'm trying to figure out whether my linter doesn't find the issue. Unexpected talk aside. Line number what? 18. What, you want me to do that? Line number 17. Pause edge of TX or so. Let's see, let's remove this or neg edge. Okay, there's something wrong then. Does anyone see anything? I have some sort of little syntax error that I'm not seeing. There's a syntax error somewhere. I have a syntax error somewhere that I can't see. And that my linter is not catching. But my builder does. Okay. We can just comment everything out and we can just go slowly. Nice. So I think I9 just says the top module is me. I think thank you for finding that for me. And then in here module main. Default net type. What is wrong? Yeah, I don't want an asynchronous one because I don't know when that will happen. So, and R? Yeah, that's fine. Yeah. And up here then I. Ah, yeah, that was the issue. That was the issue. I don't know if you saw that, but that was the issue. So let's go back here. Let's actually do a lint. It's fine. Up to build. Talk assign pipeline V. Let's look at up here now. Okay. Let's look at main.pcf. Let's look at main.v. And then let's look at pipeline.v. And then there's the other issue. There's the other issue. Assign. Let's look at now. understand. Okay, first of all, let's just comment this all out. Sorry, people. Something is wrong. Let's remove that. Somehow, this does not get seen as our top module. Just give me a moment. Somehow that does not get seen as our top module. So there's some sort of issue there. I'm just gonna go here and look at how it did this before. Main.v, main module is that module main and module main and module. Module main and module. I can make some reg m. Really? That was a problem. Okay, I'm sort of late. We need to finish this. So that was a problem. So let's actually go back and add a test bench. And I'm gonna follow what I did yesterday quite verbosely because I'm already too late. I have a branch to go to. It's on Sunday. I want to follow this this sort of thing here, and actually see if I can just copy it. It's very simple, so that's why I'll copy it. Pipeline tb v. Paste. I'm sorry I have to do this. My editor is quite stupid. So I want to find here. I want to make a pipeline TB here. Pipeline. I got a little frosted there, and I want to do a reg start. And then I won't set this to an always because I just wanted to do wait, and then I want to do start is equals to not start. So just wait and do it once, and then in here I will dump vars of pipeline TB so that we can actually see them. Pipeline TB, and then what I want to do is I want to go like let's actually see current values of, let's actually see, yeah, we can do b our txbox b, and then our xbox box b, and then what we can do is tx b, and rx b, and then I think I can always do some sort of thing here so that I have it. And then in here, let's actually do device under test, and we shall reach for the tx box, and then ut rxbox, rxbox, and then we should do dut.tx, and then we should do dut.rx, and then do we want to actually do what reset is, and then we want to look at start, so we want to look at start as well. Current values, start, start is start, and then let's do that, and then in here we can just pass in, we can actually just go start, which is not a problem, and I think that should be okay. Pipeline TB should give us a test bench, and we can actually go 150, and we can do 150 as well here. And I think we can now come here and go up here lint and see what is happening. Duty. So DUT is main duty pipeline, pipeline duty. So let's look at that. Appellant DTTX box. You said that unexpected hash. Okay, cool. So that means there's something I'm not setting right. So this is going to be start and what is it? Start here. And what? So you want? Do you want me to go like is that what you want me to do? No, but that's a delay. Why isn't that? Why isn't? I mean, we can do initial begin and something's wrong. And expecting that when I use DUT. Cool. So what are you expecting and where? Why? So where are you expecting it? DUT box. Oh yeah. So this is there's a comma here. Actually, we can just go back all the way. We can just go back all the way and just leave the thing here. So make it readable. Make it readable. And appealant. Okay, cool. So let's actually test this. We got into a place where we can do it. Up here, send. Something's not going right. Our Xbox never changes. Start never changes. So it doesn't change. They don't flip on each other. Do I want to do? Yeah, I want to figure out a way to trigger it, and then we can go. So in initial begin here, let's look at how we used to do the old tests here, and there's a way we used to kind of do a little switch here. We would do a little switch. So there's this. I don't want to do that. I just want to do initial begin, clock is not clock, and then do that. Yeah, so start is not start, and then let's see. Start is just one, it never flips, basically. If I can do that. Wait for values to settle, and then do start. What start is equal not start. That does not look right. It's always 1. It's always 0. Tx is high, Rx is low. They don't do the thing they're supposed to do. And Rx box and Tx box are not states, and they're not changing. So there's something wrong. Just trust your test case. Let's trust the test case. Ah! This is the receiver sending an ACK. Okay, yeah, this is the receiver. Let's actually make this multi-line. And we can explain ourselves here quite right. This is the receiver doing the following. And then obviously we can do and what we want to do is go back here and just put this on the next line and go back here and say following, and we can go back here, and it's so nice to trust here. I like it. I really love it that we can trust our copies the ready data. 2 sends an ACK. Okay, and then let's go back here, and then we can go and then we can say Control C. This is the sender doing the following. 1 ready's next data. 2 sends a request. There's that. There's all of that. So there's that. There's these things are happening. So this should actually give us a better result right now. And if I do up here sim, okay, device and the test. Nothing changes. That's not good. Something is wrong. Something is wrong as always. Just okay, cool. Okay, cool. And then there is a start, and then at post edge start. So start goes to 0. Start equals 1. That's good. Let's look at start. Let's look at the sim again. Is start actually treated right? Let's look at the sim. Do we treat start goes up? Start is up. It never changes. So let's look at our logic here. Assign this copies from that to that, and then this changes that. And then the moment this changes, this should be triggered. And then that should do that, and then it should trigger that. So either we are not doing the correct thing in the tests, we might not be doing the correct thing in the test. So start goes from start to start, only to start. Yeah, start is already top, so it's good. So actually we can do something like a display here. This hash display. Let's go here and we can say initial start value. Start. Start. Perhaps we're starting at the wrong place. And we want to go, yeah. So start time, end time. There's nothing. Nothing is done. Nothing is done. I don't understand why there's an error. There's nothing is done. We never do anything. Okay. Pipeline TB. What do you find? Pipeline TB for VCD. Pipeline V21 pipeline. Procedural assignments. V21. 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 So V, is it V, pipeline V, pipeline V, yes, 21, 30, 31, 21, 30, 31. Initial start value 0. Yes, so we get something. Current value start 1, TXbox 1, RXbox 001, TX0, RX0. Oh, we're not waiting long enough. We're not waiting long enough. I realize we're not waiting long enough for this to happen. So what happens if we go, yeah, this, let it settle. And then what if we go 1500? This in. Okay, cool. So there's something wrong because this you see it says finish at that one TXbox that. So there's something wrong. Something wrong. Something is wrong. Pipeline V. RX or neg edge. RX. So the wow, this is amazing. This is why simulation is so important. This is why you can't build this stuff without it. Like, it would be so hard to debug this without simulation because wow. So wow. Okay, cool. Let's try now. Up your seam. It's waiting. That's quite a long wait. Let's see. I have a feeling if I stop this, it will work now. It will have worked. Yeah, it will have worked. So something is not doing the thing it's supposed to do. So this is TX, which controls this, and this is RX, which controls this. And yeah. Initial start value 0. VCD is there. I wanna go. Wait. Did I actually save this pipeline? and then I want to go into the test bench, and I want to do just like 100. Control 8K, up here, sim. Somehow it doesn't like it when I do things like this. I'm gonna try and yeah, if I just set it here, it should X. That's not cool. So there's something I keep on doing in my test cases that actually appears sim somewhat. Ooh, okay, cool. So mainly invalid TB11, which is this. Obviously. Okay, cool. So this actually works. This actually works right now. Never changes. TX never changes. Or textbox never changes. RXbox never changes. That's okay. So now we need to know why. How do we? So now I know it's this thing of me getting the thing going. So let me look at this. How did I do this before? How did I set up something before? When did I do that clock? I always set that clock already. Do I need to do another initial begin? So it's when I do it's when I operate on this thing that is it. Do you want me to dump vars first and then wait, dump vars and then wait? And then also when we did the ADA module, we looked at there was something we used to change, and I think that was actually quite a good thing, because we would do a change and then we would let's actually look, because this is what we did this properly before. We did an initial begin where we set it, and then we would do this, and then we would wait, and we would do it again. So we can do that. We can just set it at that. Okay, so we can do a non-blocking aside. Start this equals not start. What we actually mean. And let's see, up here, same. No, this doesn't work. This doesn't work. Because look here, we set it here. Perhaps we shouldn't set it when we begin. And here, so let's not set it. And then let's come in here and do an initial begin of ourselves. Another one. And in this initial begin, we want to do start. Start is equal 0. Okay, and then in here end, and then somewhere in after here, after we do dump vars and all of that, and after we do the monitor, after we do the monitor, we want to do start is equals not start after the monitor. There could be an order here that I just haven't, there could be an order here that I just haven't gotten familiar and comfortable with. So let's up here sim 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 19 16 17 18 19 30. Okay, cool. I will do this now. I will now use a timer. I will now remove this. I will completely remove this. I will completely remove this. I have learned how to do delays. I'm gonna do that, and I'm gonna remove that. There's no input into that, and I don't need this. I don't need that. So let's just make a module that looks like that, and then in pipeline V, what we want to do is we want to do remove the start. We don't need an input here, and instead of doing that, because I set a pose edge down there, I'm gonna, instead of a pose edge, I will do hash wait, and I'm gonna do 20, and then start is equals not start. Oh, I can actually just do tx is equals, why not tx is equals not tx. Can I do this? That's the problem. Up here, int unexpected hash. Always. Let's see. Up here, sim. Yeah. There's somewhere start is being used here. Let's actually do that. I feel like I did the wrong thing, but let's see. Let's see what happens. Somehow my test benches are really broken. There's something I do not know about using a test bench that actually makes it so that I can't do test benches properly. There's some fundamental thing that I'm missing. There's some fundamental thing that I am missing that is just not, it just doesn't work. Because I either need to set an input, yeah, somehow I'm always messing up. I might have to stop here because I have to go for brunch. Let's think about one last time. So let's look at this. This has inputs and outputs, and then it just uses its inputs and output. I want to actually use the other one, and then we take the input, and then I want to see the other module. Yeah, it just assigns something. Can I do that? Can I assign that and then it will change the thing? maybe we do a deep dive into assignments, into Verilog assignments. Verilog task. Is it synthesizable? Can I go like task? So wait, I can always just do. So you need this. You see, we need a clock somehow, or I need a button. We need either a clock or a button. There's also the things I used to do to my registers. No, but this is just checking them. I never actually touched them and set them, but slow clock, yeah. So I either need to decide whether I'm going to use an input or an output, or there's some fundamental thing I'm missing where, because this would work. It's just that we don't have a way of triggering it to start the first time. Or if our Xbox 4B0 appear linked. So there's that. It never changes. T-Xbox, R-Xbox. Where's our Xbox? Our Xbox is 1, T-Xbox is 0. Right. So RX is 0, TX is 0. Cool. So this actually runs once, but so it doesn't assign our Xbox equals to Xbox. Assign RX is not even RX, so this should actually trigger this. So let's look at it now. Still doesn't. Okay, cool. I'm gonna have to stop there. it does do actually what it's supposed to do. So this TX box 000, RX box 001, this is not supposed to be the case, because what's happened here is it did RX box is equal to TX box, but then TX box is supposed to be TX box plus 1 B1, and then this is supposed to be that, and then maybe we do this, because that's the blocking part is done. We can do that, and maybe we sim. No, it's not doing the right thing. So RX is wrong, TX is wrong, time is just going. And we just do the first one and we never actually go for the next one. And unless pose edge RX, neg edge RX, begin TX or X box is that. TX box is never assigned again. Well, it's supposed to be assigned here again. Perhaps it's something I'm missing. So the way we're doing registers is we do this continuous assignments. We do this continuous assignments. Can we do cases instead of no, we can't really just do cases. What? Wait, okay, let's also look at the other module. Let's look at the other module. This is assigned, this is done. Yeah, that is what is happening there. So this is supposed to be an assign. And that should work. That should really work. And even in the binary counter one, that should work. Okay, cool. So it appears as though I'm stuck and I need to leave. So I'm gonna have to stop the stream there today. It's been what, almost an hour and a half. I'm gonna come back and I'm gonna go for brunch, and then when we come back, we're gonna find out. It's probably gonna be something small. There's some two concepts that I'm not connecting, and then these two concepts are actually the ones that are preventing me from doing the thing that I need to do. So you don't want me to go like so you don't want me to like do like that and then like go like that. And anyways, yeah, let's see what happens there. Yeah, I should see a lot more there, so that's not cool. Yeah, the Xbox should be added. What if we do this procedural block before the other one? Or if we go here and we go like, yeah, start with the SP, and then we should do that. And then we should go this is a continuous assignment. We don't want this. We really don't want this. We don't want this aside. We do want a procedural assignment there, so Yeah, we don't want that. We don't want this is a continuous, and this one as well. We don't want this as well. We really don't want this as well. Yeah, this too we don't want. And what happens now? And you're telling me they do something here. So because our Xbox goes to 1, that is fine. And TXbox goes to 0, our Xbox goes to 0. And if they both start at 0, they both start at 0. So shall we make them start at different ones? It doesn't matter. The transition, their actualness doesn't matter. It should not matter. Rx is 1, TX is 0. Okay, let's look at what happens here. Rx is 1. Rx is never changed. Someone never changes Rx. Or we're not waiting long enough. They never changed somehow. I'm making some really rookie error somewhere here. And let's remove the both edges. Let's just use a pose edge for now. Let's use a pose edge and see what happens. Let's just use pose edges for now. Let's work on one. And then control C, copy C. Still same thing. And why is TXbox going to 0? This is a continuous assignment as well. We don't want this. We really don't want this. Can you do something like that? No, I don't want that. Okay, I'm gonna have to stop. I have to go for brunch. Thank you all so much. This was an amazing one. It's really amazing that we can spend this much time actually debugging. I have a feeling when I come back from lunch, I'll have thought about this quite well, and we can maybe fix it. And if I have time later in the day, we're probably gonna do another stream so that we can actually fix it. It's officially here. The hard part of advent of code is officially here. We're struggling. So this is good. This is why we wanted to do this. This is why we're gonna do this. This is the kind of thing you figure out and you just miles ahead of everyone. Thank you so much. That was amazing. As always, if you want to support me, subscribe to the video. There's links to all the things that I've been using. And thank you so much for showing up today. And it was amazing hanging out with all of you. Thank you. Cheers. Remember to be daring, work on something that exists, and put your work out there. Thank you. Cheers, everyone. I'm going to stop now.